As per question, area of A is given 2 millimeter square, which is converted to meter square, dividing it by 1000 into 1000. Since 1000 millimeter makes 1 meter, that is why, since millimeter square is there, 2 times millimeter into millimeter, that is why it is divided by 1000 for 2 times. Similarly, area of B equals to 6 millimeter square given. It is converted to meter square by 6 divided by 1000 into 1000 meter square. Thrust given 1.5 Newton. So pressure on A is equals to thrust by area 1.5 Newton divided by 2 into 1000 into 1000 meter square. Whenever this division sign is converted to multiplication sign, we have made its reciprocal 1000 into 1000 by 2. After simplification, we will get it 7.5 into 10 to the power 5 Pascal. Now pressure on B equals to thrust by area. Here thrust is same 1.5 Newton divided by area of B is 6 divided by 1000 into 1000 meters square, which is again multiplied due to change in the sign of division. We have taken its reciprocal 1.5 into 1000 into 1000 into 6 is equals to 2.5 into 10 to the power 5 Pascal after simplification. The question is given here: a block of iron mass 7.5 kg and dimensions 12 cm into 8 cm into 10 cm is kept on a table top on its base of side 12 cm into 8 cm. Calculate thrust and pressure exerted on the tabletop. We have to take 1 kgf as 10 Newton. As per the question, mass is given 7.5 kg. So thrust will be equals to 7.5 kgf. Thrust is the weight or the force acting downwards. So since mass is 7.5 kg, whenever it will be placed on the tabletop, the thrust will be, or the force acting normally will be 7.5 kgf. And since 1 kgf equals to 10 Newton, so 7.5 kgf is converted to Newton by multiplying it into 10. So 7.5 into 10, that is 75 Newton. And area is given 12 into 8 centimeter square. Here the base is given, its dimension is 12 centimeter into 8 centimeter. So since it is in centimeter square, we have to convert it into meter square. So we have divided it by 100 into 100. 100 centimeter makes 1 meter. So 100 centimeter square, when converted to meter square, we have divided it by 1000 into 1000. Now pressure, we know it's thrust by area. So 75 Newton divided by 12 into 8 divided by 1000 into 1000 meters square. Again we made its reciprocal. So 75 into 1000 into 75 into 100 into 100 by 12 into 8. After simplification, we will get 7812.5 Pascal. Here the question is: a vessel contains water up to a height of 1.5 meter. Taking the density of water 10 to the power 3 kg per meter cube, acceleration due to gravity 9.8 meter per second square, and area of vessel 100 centimeter square, calculate the pressure and the thrust at the base of the vessel. Since height is given 1.5 meter, density equals to 1000 kg per meter cube, G that is acceleration due to gravity 9.8 meter per second square. Area A equals to given 100 centimeter square, which is converted to meter square again by dividing it 100 into 100, since 100 centimeter makes 1 meter. Now we will use the formula of pressure equals to H rho G. Substitute the value of H, rho and G. We are getting 1.5 the value of H into 1000 the value of rho into 9.8 the value of G. After simplification, we will be getting 14,700 Pascal. Thrust equals to pressure into area. This is the formula. Since pressure equals to thrust by area, so from that formula, when thrust is calculated, it's pressure into area. Now pressure we already got 14,700, and area in meter square, which we had already converted to meter square. It's 100 divided by 100 into 100. After simplification, it will be coming 147 Newton. Here the question is given. The area of base of a cylindrical vessel is 300 centimeter square. Water density equals to 1000 kg per meter cube is poured into it up to a depth of 6 centimeter. Calculate the pressure and the thrust of water on the base. G equals to 10 meter per second square. As per the question, depth is 6 centimeter. So we have taken H equals to 6 centimeter, which is converted to meter by dividing it by 1000. 6 by 100 meter. G given, it's equals to 10 meter per second square. Density, that is rho, equals to 1000 kg per meter cube. This is also given. Area equals to 300 centimeter square, which is converted to meter square when we had divided it by 100 into 100. Now we have to calculate the pressure. So pressure equals to H rho G. H, that is 6 by 100, rho, that is 1000, and G, that is 10. After simplification, it's coming 600 Pascal. Now thrust equals to pressure by area. Pressure which we have already calculated, it's 600, and area, that is 300 divided by 100 into 100 meter square. After simplification, this is coming 18 Newton. Here the question is, calculate the height of water column which will exert on its base the same pressure as the 70 centimeter column of mercury. Density of mercury is 13.6 gram per centimeter cube. We know that density of water, here we have taken it as rho 1 equals to 1 gram per centimeter cube. Density of mercury, which we have taken rho 2, it's given 13.6 gram per centimeter cube. Let the height of water column equals to H1 and height of mercury column equals to H2 we have taken, and its value is given 70 centimeter. Here, as per the question, pressure exerted by water column will be equals to pressure exerted by mercury column. So we can write H1 rho 1 G equals to H2 rho 2 G. Now we will substitute the values. H1 we will keep it as H1 into rho 1, it's 1, into G equals to H2, that is 70 centimeter, into rho 2's value is given 13.6 gram per centimeter cube, into G. Now G will be cancelled on both sides. So we will be getting H1 into 1, which means H1 itself, equals to 70 into 13.6 equals to 952 centimeter. Since here all the datas are given in gram per centimeter cube, so the H1 which we have got it in centimeter, 952 centimeter, which can be converted it into meter when we will divide it by 100, and we will get its 9.52 meter. The subpart of the question is, will the height of water column in part A changes if the cross section of the water column is made wider? The answer is no, because the pressure is not going to change if the cross section of water column is made wider. Here the question is saying the pressure of water on the ground floor is 40,000 Pascal and on the first floor is 10,000 Pascal. Find the height of the first floor. Take density of water 1000 kg per meter cube and G equals to 10 meter per second square. Here the difference in pressure due to the height only, that is 40,000 minus 10,000 equals to 30,000 Pascal. Let the height of the first floor be H. So H into rho into G equals to 30,000. Now substitute the values. H into density 1000 and G is 10 equals to 30,000. So H equals to 30,000 by 1000 into 10. After simplification, it will become 3 meter. A simple U-tube contains mercury to the same level in both of its arms. If water is poured to a height of 13.6 cm in one arm, how much will be the rise in mercury level in the other arm? Given density of mercury equals to 13.6 into 10 to the power 3 kg per meter cube, and density of water equals to 10 to the power 3 kg per meter cube. Let the height of water be H1 equals to 13.6 centimeter. Since here the density of mercury or density of water is given in terms of kg per meter cube, so 13.6 centimeter we will convert it into meter by dividing it by 100. So 13.6 centimeter equals to 13.6 by 1000 meter. Now density of water is given, which we have considered as rho 1 equals to 1000 kg per meter cube. Let the height of mercury is H2 and density of mercury, let it be rho 2, and it is given 13.6 into 1000 kg per meter cube. Now pressure exerted by water column in one arm will be equals to pressure exerted by mercury column in other arm. So we can write H1 into rho 1 into G equals to H2 into rho 2 into G. Now let's put the values. H1 it's 13.6 by 100 into rho 1 it's 1000 equals to H2 into rho 2, that is 13.6 into 1000. Here we have not written G because G is cancelled on both sides. Now after simplification we will get H2 equals to 1 by 100. Because 13.6 is cancelled from both the sides, 1000 is also cancelled from both the sides. So H2 will be remaining 1 by 100 meter, which is equals to 1 centimeter.